right, so then we're going to look at the last section in the P chapter, which is section P-5. You're going to want some colors. And perhaps a highlighter. All right, so we're going to look at specifically inequalities, graphing them, interval notation, that kind of thing. So as I look at these, and here's what you really need to do with your highlighter. Remember, if you multiply or divide, because it can occur either way, by a negative number, you must flip the inequality sign. And the only other time you flip the inequality sign is if you flip-flop the left and right side of your inequality. You have to play Vanna White and flip the inequality sign also. So that would be the only other time. So all of these down here, we're going to graph them on a little brief number line. And we're going to talk about the interval notation that's associated with them. So if I'm asking you to graph x is greater than 2, 2 is called your boundary point or a critical value. And you don't have to have 0 on your number line. It might end up that you have 0 on your number line, but I like to put my boundary points, I don't know, typically in the middle. And then some other numbers to the right and to the left. But you can't just put the boundary point in there and nothing else. True story, there are some of you that don't know that negative numbers are on the left. It's true. So I need to correct that if that's an issue. All right, so greater than signs, is that an open circle or a closed circle? It's an open circle. So I'm going to put an open circle at 2, and your inequality sign does stand as an arrow pointing to the right, meaning everything greater than is to the right. If your variable is on the left-hand side, you can look at it that way. You're going to see some teachers are going to graph it not with open and closed circles, but parentheses and brackets. Isn't that part of interval notation? So you might see them graphing it like this, actually on the number line with the parentheses, and then making this really, really dark. The only reason why I don't like that is because it's hard for me to see where your arrow is. If you want to do that above the number line, that's fine. You can do that. And then your interval notation would be, and the reason why they use those parentheses and brackets is because it's part of interval notation. So because 2 is not part of our answer set, and 2 comes before, what direction is this? Positive what? Numbers go that way for how long? Infinity. So it's positive infinity. So because 2 is not part of it, we put the parentheses. And then your positive infinity is to the right of 2. You cannot have positive infinity on the left side. And so there is your notation for that. Then if you look at x is less than negative 3. So negative 3 is your boundary point. So this time, if I'm going to use parentheses and brackets, what would I use here on my number line? Yeah, I'd have a parentheses. So make sure it's clearly a parentheses. And then I would prefer you put your arrow and your parentheses kind of up top there, if you're going to do that. Question?
So, do you want us to use parentheses, do you want us to use the open circle?
I don't care, whatever you're more comfortable with. And you'll see your upper math division teachers doing it this way, more so than this way, only because it relates to interval notation. So then, is negative 3 part of our solution set? No. So in my interval notation, what goes on the left? Negative infinity, because that comes first. Oh, sorry, it looks like an 8. And then negative 3. I haven't done that in a long time. All right, so then on this one, negative 1 is our boundary point. So this time I have an equals to sign underneath my inequality. Doesn't that mean a closed circle? Okay. And then I'm pointing to the right or greater than, so an arrow to the right. Again, your teacher might do brackets like this and then an arrow to the right. Either way is acceptable. I don't care which. So that kind of tells you what your interval notation is. Since -1 is part of the solution, you want to bracket -1, and then it's going infinitely to the right, so positive infinity. And then last one. I want you to do this one all by yourself. Such a toughie. So show whatever notation you want to for the number line, and then your interval notation below it.
It's positive and why is it even line?
Whoops. Because my brain's not functioning. Yeah, see, some of us don't know. Oh, good heavens. That's what head colds are going to do to you. I'm working backwards today. I still haven't had any issues. Correction tape. I've only used it, what, once in this class?
Three times.
You people are counting?
Yes.
Good heavens. And look, you have a tally. Look, it's not even working. It doesn't like me. Okay, so it's not just me, right? This thing stinks.
Yeah. Oh no, it's never worked for you.
Oh, for me.
It's never worked.
Because it's not used to it. It's not used to me making mistakes. Oh, jeepers. Okay, well that's just gonna, that's my family's, that's a big smudge. That looks so much better. Okie dokie, here's my 6. 5, 4. See, now it looks like a 4.
Yeah, right.
Oh, stop it. All right, good enough. Good enough for government work. All right, I'm assuming you have your answer by this time. All right, so if you're using bracket notation, because your arrow is going to the left, your bracket has to open to the left. Same thing with if you're going to use your parentheses. It has to open in the correct direction. And so then you have negative infinity, and then 6, and then bracket. So again, you never have a bracket on your infinities. They're always parentheses. Any issues with that? We're going to have some more complicated interval notation as we go along, but that's your simple stuff. Okay, so then this one we're going to solve by algebra. We're going to graph it, and then we're going to state the interval notation. What do you think would be best to do first? Even before that, what's in there that you don't like that looks ugly? It's a fraction. I would get rid of that fraction first. Get rid of it, and the rest of it's a piece of cake. What's the denominator of that fraction? 2. So multiply every single term here by 2. And then including the x and including the -4. So you've got 4 things there you're multiplying by 2. So I get 2, my 2's cancel, minus 3x, greater than or equal to 2x minus 8. To avoid having to multiply or divide by a negative and then having to remember to flip the inequality sign, if I were you, I would avoid a negative coefficient of my x at all costs. So isn't the negative 3x smaller than the 2x? Isn't that smaller? That's the one I would choose to move, because here's my left and right side of my inequality, right where the inequality sign is. Add a 3x, add a 3x. So you're left with 2 greater than or equal to 5x minus 8. Major issues today. Then the rest of it's a piece of cake, right? Add 8. And divide by 5. So I have 2 is greater than or equal to x. When I have an inequality, I never ever want to look at it with my x on the right. So if I switch the x and the 2, which is your symmetric property, because of that, I have to remember to flip my inequality to less than or equal to. If I don't, my answer is going to be wrong. So 2 is your boundary point, or as your book likes to call it, your critical value. So then you've got to check, or you've got to graph and check. So here's your number line. So I'm going to do it right this time. Here's 2. And then you graph it however you would like, and then show your interval notation. I can hear Nelson all the way over here. Noelle, would you like to close the door? All right, so you should have a bracket at 2 or a closed circle at 2 and an arrow going to the left. Say that again? Oh, thanks. Oh, gosh, did I do something wrong again? So there's your bracket and your arrow to the left. So don't I have negative infinity on the left and 2 on the right with a bracket? So there's my interval notation. Right, so that's review, am I correct? Mm-hmm. Okay, so flip it to the back. Although we've talked about this, we're going to really focus on interval notation for example 2. The interval notation starts to get a little bit dicey. And notice that for example 2, I have exactly the same problem with the exception of what? Yeah, the signs are flipped. It does change how your graph looks and it changes how your interval notation looks. So let's go ahead and solve this. So for absolute value problems with an inequality no less, we have to do 2 different equations. So I've got to do the first equation exactly as it looks. But then the second equation, keep the x minus 5 exactly as it looks, flip the inequality sign, so in this case 2 greater than. And then I'm going to change the sign of everything on the right side because there's only one thing, it becomes a -2. So if I were you, I'd write yourself a little note, flip the inequality and multiply the right side by -1. So it's going to happen here. And we're going to do it on the other equation as well in a minute. And then we are going to have to come up with a word here, and or. You're going to decide whether it's and or once you look at the graph. So solve those. Those are simple to solve. So this time I have 2 boundary points, or 2 critical values, 7 and 3. This one says x is less than 7. And this one says x is greater than 3. So if I had an open circle or a parentheses at 7, and an open circle or a parentheses at 3, wouldn't my line go in between? Wouldn't it look like this? Okay. Is that an and or an or statement? That is an and statement. All right, so this is part of your answer. Your graph is the second part of your answer, and then you will most likely be asked for interval notation. So for this one, it kind of looks like an ordered pair because the 3 and the 7 are your critical values, and then what lies in between, we're basically saying we start at 3 on the number line. We don't include 3, so it's an open parentheses. And then we stop at 7, but don't include 7, so it's an open parentheses. It does look like an ordered pair, but it's not. This is your interval notation. So that one looks a little odd. All right, then, this side, go ahead and set up your two different equations. Remember to flip your inequality and solve, and you're going to get similar answers, but they look different. You might want to add an arrow in your note over here that we also have to flip and change that sign. So those should be your two inequalities. So didn't I get the same boundary points? But look at your graph. Bless you. So this time, if I have x is greater than 7, greater than or equal to, don't I have a bracket this time at 7? But an arrow going to the right. And for x is less than or equal to 3, I have a bracket at 3 and an arrow going to the left. Is that an and or an or statement? So that's definitely an or. It cannot be in both of those places at once. Only one or the other. And so, what do you think your interval notation looks like? Do you remember for this one? Well, I can't do it like this with brackets.
Yeah, sure.
So what am I going to do? How are you going to show it? You're right. I do have brackets, but what else do I have in there? What does just that one look like? What's the notation for that one? Negative infinity, 3. I have an open parenthesis here and a bracket there, right? Then what does that one look like? Bracket 7, positive infinity, right? But then, to pull the two together, you have to draw their union. So, you remember that symbol from Algebra 3-4? There's your union. Union, U. And so this is your proper interval notation for an or statement.
So we don't have that union as well.
Correct. You need to have it in there. Because it's showing that you're connecting the two together as one statement. It's kind of like if you don't have your or in there, it's wrong. All right, any questions on that? Okay. Then, this is the last one that we're going to do for today. It's a little bit of a doozy. All right. So what's the first thing? That's an issue. Yeah, we need to, first of all, set one side equal to 0. So in order to do that, and you can show that work if you want to, or you can do it in your head, I don't care at this stage of your algebraic career. So then we've got 2x squared plus 5x. We're going to subtract 12 to move it over is greater than 0. So this was step 1. Aren't there several ways that we could solve that quadratic? We could either factor with group and garbage, however you get there, or you could use a quadratic formula. Would I want to complete the square here? No. Why? Well, there's two things going on. Thing number 1, there's a coefficient in front of the squared term. That has to be 1. And thing number 2, that's not divisible by 2. So both of those out. So I'm going to show you how to factor using group and garbage. You can use a quadratic formula if you want to. It's your choice. So, step 2, factor, using group and garbage. So that's factor by grouping, for those of you who don't know what that means. So here's my crisscross. I've got my bookends that I'm going to multiply together. So 2 times negative 12 gives me negative 24. I want my middle term at the bottom, positive 5. So I have to come up with the factors of 24 that subtract to give me 5. What factors of 24 subtract to give me 5? 8 and 3. So I've got a 3 and an 8. The biggest of these two is 8, so it carries the sign of the middle term. The 3 better be negative in order for those to combine to give me a positive 5. And then these are my two new middle terms. So this is my negative 3x and my positive 8x. They're going to replace the 5x. So I'm going to rewrite. So then 2x squared, instead of my 5x, I'm bringing in my two new middle terms. Minus 3x, positive 8x, minus the 12, greater than 0. This is where Baker comes in with her twosies. Cut it in half, take the greatest common factor of each group. GCF here is x. Divide each of those by x. Don't I have 2x minus 3 left over? And then the second grouping, I'm going to factor out between these two a positive 4. So divide each of those by 4. And lo and behold, I get 2x minus 3, which is exactly what I want. I want those two to be the same. So now I can factor that out one more time in front of parentheses. And then pick up your garbage. Here's your garbage. And throw it in the empty trash bin. Done. Then set each one of those equal to 0. So step 3, this is step 2. Step 3, find your solutions. So 2x minus 3 is greater than 0, and x plus 4 is greater than 0. So there's two of my solutions. I have to check them. Because the oddest things occur when we factor with inequalities. So you should end up with two critical values. Is anybody not here yet? Okay. So then your fourth step is going to be to graph. Graph and check your critical values. Alright, so up here, I'm going to graph it. And it's weird because I have to graph a fraction. And what these critical values do is they cut the number line into 3 parts. Dakota, if you're taking notes, you can't fall asleep. Or if you're standing up, you can't fall asleep. Your choice. Alright, so I've got a negative. So here's my negative 4. 3/2, isn't it 1.5? Right here is my 3/2. So it basically cuts this number line into these 3 parts right here. I'm going to have to check to the left, in the middle, and to the right. Be smart about the points that you choose. You don't have to choose points that you physically see on that number line, especially what I'm talking about is out here. Like, one of my favorite points to check, 0, what else? 10, and then sometimes 1. It just depends on the problem. So let's check 0 first because it's really easy. So if you check 0 in the original problem, won't this become, this side is 0, and isn't that 12? So I am evaluating under 0 that the left side of my inequality, if I plug in 0 to x, I get 0 is greater than 12. True or false? False. So this is false, which means that nothing in between these two boundary points should be part of the solution. There shouldn't be a line there, no matter what this looks like. It doesn't say that x is greater than 3/2 and x is greater than -4. Doesn't it look like it should be all of this or all of this? Well, this shouldn't be part of there at all. Then I want to check to the left. But one of my favorite numbers is 10. Can't I check -10? So I'm going to check way over here to the left, -10. Somewhere off there to the left. So I'm going to plug -10 in mentally. -10 squared is 100, right? Times 2 is 200. -10 here is -50. What's 200 and a -50? Yeah, 150. So this is giving me 150 on the left. Is that greater than 12? True or false? Gee, that wasn't even part of one of these solutions, was it? There's a surprise. If you double check it, it does work. Weird things happen with inequalities. So we do have to show that everything to the left of -4 is a solution. And then, is -4 going to be included? No. So technically I have a parentheses here and an arrow to the left, right? That's what that's saying. I have no arrow or no line in between here. Then we have to check to the right. My favorite checkpoint 10 is to the right over here. So I'm going to check that one. It gives me almost an identical solution. 10 squared is 100 times 2 is 200. But 10 times 5 is 50. What's 250? 250. Is that greater than 12? True or false? So that is also part of the solution. So anything to the right of 3/2, so I need a parentheses and an arrow going to the right. So that's really an or statement, isn't it? So technically this is my solution in inequality state. So I have to have x is less than -4 or x is greater than 3/2. So that's my true solution. Now what does it look like in interval notation? Remember what we did above? What's that in interval notation? -infinity, comma, -4 with a parentheses. So -infinity, -4, both of those are in parentheses, and you're right, somebody said I need a u, correct? And then what's this side? Parentheses, right? 3/2, comma, positive infinity. So there is your interval notation solution. These are the same solutions, they're just given to you differently. So you might want to write down here that this is going to be day 2, so we'll do this tomorrow, so this is day 2. And this is problems number 63 and 64 on tonight's homework. So don't do this part, and if you flip this over, then that meant that this was day 1. So tonight you're going to do everything but problems 63 and 64. I will discuss domain tomorrow and then let you finish 63 and 64 in class and come bring it to me. And then you have a test on Friday. So you'll have 2 days to study for that test.